operational.
Okay. Right. Good morning, everyone. If you have any, please put your questions on the chat till other student shows up. So can we go over which section, Sarah? 10.1. Sorry, I didn't see 10.1. All right. And okay. Any other questions from 10.5? All right. Number 14 can from also 10.1 or 10.5? Okay. All right, so we can start 10.1. We will do all of them. So I start by order. So number 13. And we are in section 10.1. So I will write this because I usually scan those paper and put them on Blackboard in case you guys didn't have the time to write them up. So let's look at number 13. Number 13, we have the following. Eliminate the parameter to find a Cartesian equation of the curve. Then sketch the curve and indicate within arrow the direction in which the curve is traced as the parameter increases. So number 13, we have x equal the sine of t and y equal the cosecant of t, and the range is t between 0 and pi over 2. Okay. So the question is, they want us to eliminate the parameter. So questions? Anybody said anything? Okay. So how do you want me to eliminate the parameter? I need to find a relationship between x and y. Basically, that is by eliminating the t. So anybody has any idea what you want me to do? Ideas?
Change the cosecant to 1 over sine and then put x in.
Okay, let's do that. So I need to find something that relates them. So what's cosecant? So y equal cosecant t. Now the cosecant is 1 over the sine of t. And now what's going to be the relationship? Of course, so we have y is 1 over sine, and x is the sine. So y.
They also have an outline plus thesis or short draft due on Friday. That way.
Okay. So this will give me that y equal 1 over x. So that's the relationship between them. And so this tells me that the graph somehow should look like this. That's the graph of 1 over x. But now I have a range to work with. So the second part is we're going to actually go back and start to look at this range and try to sketch the graph. So I know I know that that's going to be how it's going to look like, but which part of this graph I am really interested in. And that's what this problem is about. So that's part A. So that's the relationship between them. And now part B, what we have to do is we're going to plot some values and see what is the picture. So this is the x, which is the sine, and this is the y, which is the cosecant that all of us basically don't like. All right, so let us take some values, and of course we know why they removed 0 here, because for t equal to 0, y is not defined. And we know why they removed pi over 2, because for t equal pi over 2 also, for t equal pi over 2 also things don't make sense. So let us see what's going on. I will study 0 and pi over 2 in a second. So for, let us say, t equal pi over 3, for example, or pi over 6 for that matter, the sine is going to be a half. And we know what the y is. It's 1 over the sine, which is equal to 2. So at pi over 4, that's the square root of 2 over 2, and that's 2 over the square root. So basically, that's really what the picture is. So let us take pi over 3. The sine is, and this is 2 over the square root of 3. So we definitely know that, let us redraw the graph here. So for t equal pi over 6, I am at a half and a 2, so I am right there. For t equal pi over 4, for t equal pi over 4, so basically I know that the graph of sine, I have an idea of the graph of sine. So the graph of sine goes like that, and this is my pi over my pi. So this is the pi over 2. So we know that the x component is actually increasing, because that's what and the y component is decreasing. So the x increase, it means we're moving to the right. The y decrease, it's moving down. So this is going to go down like that. And that's really the direction of motion. And the question is, what happened when x become close, when t become close to 0? And what happened when t become close to infinity? So we can study this. When t goes to 0, what's the picture? The x is the sine of t, become close to 0. And the y will do what? It's 1 over the sine. It means the y is going to go to plus infinity. So when t is close to 0, the x is close to 0, but the y is going to infinity. And this is really to describe this piece of the graph. Now, when t goes to pi over 2, x is sine of pi over 2, which is 1, and y is 1 over the sine of pi over 2, which is 1 as well. So when t equal pi over 2, x and y are 1, so this is right there where we're going to stop. And that's how the picture will look like. So at 0, y goes to infinity, x become close to 0. We have this idea, and then it keeps going till pi over 2. But at pi over 2, we are right there. And that's the graph. All right? Questions before I move on? Why the chat is not showing. Okay. All right. So we move on to the following numbers. So this was number 13. I'll move on to number 14, and then I will go back to number 27. So number 14. Okay, we have x equal e to the t. Y is e to the, sorry, minus 2t. Okay. So this is minus 2t. And the question is, we need to find an equation that relates x and the y, which is independent of t. Okay, so I will back to you, and I want ideas. And then we're gonna graph it. So we know how the object is moving, because that's really on the back of my mind. Something is moving. Okay, ideas. What do you guys want me to do? I want an equation that relates the x and the y. Okay, Sarah is that x is 1 over e to the 2t. She's absolutely correct. So far, so good. All right, keep talking. I have to find the relationship. How can I find them? Then pull out the 2. All right, let's see what she's suggesting. I have to relate this piece to that piece. So e to the 2t, we're writing it as e to the t, the whole thing squared. That's the property of exponent, because we know what the property of exponent. A n to the power m, that's a times nn. So this is the power exponent I'm using. E to the 2t, I rewrote it at e to the t squared. And of course we did that because we want to relate the x and the y. So this will give me y is 1 over x squared. So that's really the relationship between them. The graph of y equal 1 over x squared, we actually know how the graph looks like. Or you can pull it up, the graph really look like this. But now, if we imagine something moving, the question is, how is it moving? Is it moving this way? Is it moving that way? We really don't know unless we start studying how the x and y are changing with t itself. So this is part A. Part B, I would like to know the graph. So how we are moving. Okay. We can plot point, or we can think about it. So let me plot few points. So this is the x, and this is the y. So I will take not a lot of values to make it a little bit real. And then we're gonna plot them here. We have an idea how it's gonna look like, but let's know the direction of motion. At -2, I have e to the -2, and this is e to the power -2 times -2, e to the 4. So at t equal -2, I am at the point e -2 and e to the 4. So e to the 4 is really, really big. E to the -2, it means that's a positive number. So let us assume the point is right there. This is t equal -2. That's really the point. At -1, I am at e to the -1. And right here, I am at e squared. So now, is the x component increasing or decreasing? Is the x component increasing or decreasing? What can you say? What is the x? X is e to the t. So it's increasing. As the input increase, it's increasing. So we know that the x is increasing. It means we know that we're moving to the right. Now, how about the y? The y definitely decreasing because it's to the -2. So we're actually moving to the right, but we're moving down. So that's how we are moving. So this is the value at t equal -1. At t equal to 0, I am at 1, 1. So we're going to keep going down. So I am at 1, 1. It's going to be something like this. At 1, I am at e, and e to the minus 1. X increasing, we're moving to the right. The y is losing values, we're moving down. We're moving down, we're moving down, and we're going to get this piece on. So y equal 1 over x squared picks up both branches. That's the graph of y equal 1 over x squared. The one I'm interested in, this is gone. We are not interested in this piece. We're actually only interested in this piece, and that's the direction of motion that we have. So to figure out the direction of motion, we ask ourselves, as t increases in value, what's happening to x and the y? We can plot points, which is easy. Or we can sometimes, as a reinforcement, start asking ourselves, what is the x and the y doing? And this has really helped me in the picture itself. Okay. Now we still have number 26 that I will definitely go over, but I want to see your answers to some other, no, 27. I want to see your answer to other problems. So let me pick number 12. And I want to see, you guys want to tell me what you did with number 12. So number 12 was x equal a half cosine theta and y equal 2 sine theta. And my theta varied between 0 and pi. All right, part A usually, for some reason, they want you to eliminate the parameter theta and find a relationship between x and y. So you guys did not ask me this problem. It means you knew how to do it. I want answers. What's the relationship between them? Isolate the sine and cosine using the trig identity. We will do that because that's what we did yesterday. So I'm going to isolate the sine and the cosine. So I will isolate it in the first one. So this will give me that the cosine is 2x. I'll isolate it with the second one. Give me a half y equal the sine of theta. Now we put them together. The cosine squared plus the sine squared equal to 1. So this would give me what? What's the cosine squared? 2x squared. Plus, what's the sine squared? It's a half y times a half y. It means 1 over 4 y squared equal to 1. So as theta goes from 0 to pi, the point x and y will be located on what type of a graph? It means this here is the equation of what? Quickly. This is the equation of what? Absolutely not. Absolutely not. That's an absolute ellipse. That's 4x squared plus 1 over 4y squared. To have a parabola, it's, remember, parabola is y equal x squared. For a parabola, the power of y has to be 1. That's what will bring up a parabola. That's absolutely an ellipse. So before I go to part B, so we know how we're moving on the ellipse, this tells me that the object physically is on an ellipse. Where it starts, where it ends, I have no idea. I have to go back to this to part B. But I know that it's gonna move along an ellipse. So let us make this into the standard form of an ellipse. So just to basically recap a little bit last section. So to make it really look like an ellipse, I have to rewrite it as a square over b squared. This is already a 1. Now, 4 here to be able to rewrite it as x squared, I'm going to manipulate this algebraically and write it 1/4. I'm not changing anything. Now I wrote it in the format for a standard ellipse. So in this scenario, my b will be a 2. That's the b squared. And this is the a squared. It means making my a to be a half. So this tells me that, so we're gonna draw it. That's the b. That's the a. And the object is moving along here. So that's the path. That's one way to think about it. The path is the ellipse. But the question is now, is he covering the whole ellipse? And where is the object starting? Where is the object ending? And then which direction is it moving? Is it moving clockwise? Is it moving counterclockwise? That's the part that this elimination do not answer. So the elimination does not answer the direction of motion. The elimination do not answer the starting and the ending point. Only thing the elimination tells me that this is the path. It's an ellipse. So now I'm going to go to part B and graph a little bit to see, okay, what is really going on? I know it's moving on an ellipse, but how is the object moving on an ellipse? So part B is, again, I will take some values or I'll analyze it. It's really up to us, up to you, or sometimes I do both. So theta between 0 and pi. So they want us to avoid 0 and pi, but this is not really hard to do. So let's do that now. Okay, so I need something to write on. Okay, so let's do it. Let's do that, and I will pick some values, and I did yesterday. We will pick up values that really make sense to us. We will not pick values like 1 and 2, because so now where is the x and where is the y? So I will pick 0, but then I will remove it when I start graphing, because they tell me that they don't want 0. But it's nice to know what's happening here. So at 0, the cosine is a 1. The sine is a 0. So now I'm starting to graph. I know that I am on an ellipse, but now I'm starting to analyze where I'm starting, kind of. So x is a half and y is 0. So x is a half and y is a 0. We're starting right here. So we're starting at the edge of the ellipse. And then are we going clockwise or counterclockwise? What do you think? Clockwise or counterclockwise? Do you think I'm going to be moving here, this way, or that way? Counterclockwise. Do we agree with Lori? Okay, I will look at the x. X is half cosine theta. It means the x is start here and going like that. That's the cosine. So according to this, the x is decreasing. If x is decreasing, it means we're going to be moving to the left. So I know that I'm moving this way. But I don't know if I'm moving up or down. So I go to my y. And this is 2 sine theta. My y is increasing. If y is increased, it means we should be actually moving this way. Okay, so absolutely counterclockwise. If you couldn't analyze it this way, but you should, you guys are smart enough to do it, I can start plugging some values and to make sure I'm not really goofing. So at pi over 2, the cosine will give me my 0 and the y will give me a 2. So this is the point that's at t equal pi over 2. And in between, we're moving along the ellipse. And then we can move, okay, it should be a better ellipse, but that's okay. And then we're gonna move all the way up here. So this parametric equation describes, if you want, an object which is moving along an ellipse. And this is the B of the ellipse. And this is the A of the ellipse. moving along the ellipse and it's moving in a counterclockwise direction. It's not covering the whole ellipse because we have restriction on the domain of theta. Right, so now we finalize with your last problem, which is, I'll pick it up, 26, I guess. 27. Very good. So let's look at number 27. Okay. So what is in number 27? In 27, they did not actually give you a formula to work with, but they give you graphs. So basically they are working with this scenario. They are giving you those two and they want you to graph the function. So which is okay. So let's do number 27. So the first graph tells you how the x component is changing with time. And the second graph is telling you how the y component is changing with time. So let's see how the x component. The x component is going up here and this way. That's how the x component, -1, 1, and 1. So it's domain between -1 and 1. The y component seems to be going like that. So that's a y. The y, that's time. So here, this is time. And this is a 0. And this point, this should be 1, 1 accordingly. And now I need to sketch the graph. And let's see how we're going to do it. So this is, so always imagine we have something moving. I know what this graph tells me how the x coordinate changing with time, how the y coordinate changing with time. So now I'm going to sketch how the object itself is moving. I can take values, we will, and we analyze. We're going to do as I did before. I take values and analyze the graph. So this is time. This is the x coordinate at this given time, and this is the y coordinate. And the values that are really make sense, -1, 0, 1, because this is what they gave us. At -1, the x coordinate is at 0. And the y coordinate, that's the -1, seems to be at 1. At 0, the x coordinate is at 1. The y coordinate is at 0. And finally, at 1, the x coordinate is at 0. And the y coordinate is at 1. Now let us put the whole thing together, graph and values. All right, let's see what's going on. When t is -1, x is 0, and y is 1. So I am right here. That's the 0, 1. And then what's happening? At t equal to 0, I am at 1, 0. So at t equal to 0, I am right here. And what's happening in between? What's happening in between? Between -1 and 0 up to here, x is increasing. The x coordinate. If the x coordinate is increasing, so my x coordinate was, am I doing something really wrong? You guys should tell me you're mixing things up. My apology. At t equal -1, I am at 0, 1. Because when I started analyzing, I realized my numbers are not making sense. And at t equal to 0, I am at 1, 0. Sorry. Okay. And now, yes, thank you. Thank you, Jordan. Very good. So now, when x is negative, between -1 and 0, the x is increasing. It means we're moving to the right. That's how I figure out immediately I'm doing something absolutely stupid when I put those points. What does the y doing? The y is decreasing. If the y is decreasing, it means we're going down. So I go back to my graph. I said, okay, we're moving to the right and down. It means we're doing something like that. It doesn't have to be a line. You don't have to worry about that piece. Now what's happening after that? We are here. Then at 1, t equal to 1, x is 0, 1. So at t equal to 1, I am also here. So I am right here at 2 different times, at 1, at -1. But how is the graph doing? The graph is actually, there is a symmetry here. Between 0 and 1, what's really going on? X decreasing, it means we're moving to the left. Y increasing, it means we're moving up. So what's really going on here is that the object is, because of the symmetry of the graph, the object is moving backwards. So that's really what's going to happen. So the object starts here, go all the way back here, and then move backward all the way back to where it started with. So it's going to traverse basically this curve twice. One way going down and another way going up. Okay. All right. Any other questions before we proceed? Very well. Please make sure you can do all the problems involving ellipses and hyperbolas. Don't, because you could not answer the questions quickly when I ask. So please make sure you do them. And you can complete the square correctly. All right, so today we're going to move on with parametric curve, and we're going to talk about the tangent line to a curve. So we start. So suppose we have a curve, a function. And this curve is given parametrically. It means the x and y are given in terms of a parameter t. And the question is, what's the slope of the tangent at a point? So let us go back and see what is the slope of the tangent. It's the slope of the tangent, nothing really, it's the same thing as usual. So suppose now I have this curve. I don't know how it looks like, something like that. That's my curve. And the x and y are given by formulas. So x is given function of time, y is been given as a function of time. Usually, if I give you y as a function of x, so if y is given as a function of x, y is a function of x, for example, and I tell you find the slope is dy dx, and we compute the derivative. Now, I don't have y as a function of x because we decided yesterday we cannot do that. So the question is, if x is given in terms of a parameter t and y, how can I still find the slope of x? So this is the line, that's the tangent line. And the question is, what is the slope? And this time I have to find it in terms of those two functions. The slope is the slope, nothing changed. So the slope is dy dx. Means if I take any point here, what is the slope? If you guys remember, which you should, what we did, we took a point very close by and we computed the change in y over the change in x. That's how we computed the slope. And then at this point, so we fix this point, we move tiny bit away from it, and we compute the change of y over change in x. And then we put a point which is closer, and we computed the change of y over the change in x. So that's what the slope is. So this is what nothing more than the change in y over the change in x when the change in x basically go to 0. But the problem now here is, that's the problem, that I don't have y as a function of x. So what gimmick I'm going to play to be able to find the slope? Now there is a formula in this problem. I will give it to you, but I give you in how this formula is really come up from. Okay, we're gonna play a game, and I'm gonna put this delta y over delta t, delta x over delta t. Okay, so this is an algebra game we're going to play. Why do I do that? Because I don't know how y, I don't know y as a function of x. I know y as a function of t and x as a function of t. So I introduce this delta t, which is actually algebraically is the same thing. And then I say, okay, when delta x become close to 0, also the time is going to be very small, of course. So the time is going to be very small. So this is going to become close to the derivative of y with respect to t, that's the numerator, and this will become close to the derivative of y with respect to t. So the slope of the tangent line, now you guys have all the notes clear. So the slope, so if x is given as a function of time, then the slope is going to change. It's going to become dy dt, how to y change with respect, divided by dx dt. So that will become the slope. I will do two examples. The first one is straightforward to emphasize one point, and the other one is a little bit harder, but not by much. So we're going to use this formula. So the first example is straightforward for a reason why I have a straightforward. So example number 1. This one, I don't think I have it in your notes. Suppose I have a curve which is given parametrically like this. X equal y and y equal t squared. Very simple parametric equation. And I want to use this formula to ask you the following question. Fine. Now, if I graph this, we will get a parabola. And in a minute, everybody should see that this is a parabola anyway. So my question is, find the point on the parabola that corresponds to t equal to 2, for example. So what's the point that corresponds to t equal to 2? Okay, if t equal to 2, x is 2, y is 4. So that's the point that corresponds to 2. Question number 2, I want to use this formula to find the slope. Now find the slope to the curve at t equal to 2. Okay, what's going to be the slope? We'll apply it verbatim. So derivative of y with respect to t. Derivative of y with respect to t is 2t. Divided by the derivative of x with respect to t, which is 1. So the slope at any point for any value of t is 2 times t. So at t equal to 1, at t equal to 2, the slope will be 4. So the slope is 4. Okay. Now, as I said, this is a very simple example to elaborate one simple idea. Now, in this particular problem, is it easy to find a relationship between x and y? Is it easy to find a relationship between x and y in this particular problem? I want an answer. I want quick. Absolutely. And what's the relationship between x and y in this problem? In this particular problem, the relationship is, so in this problem, it means if I try to express x as a function of y, in this very simple problem, right there, the relationship is y equal x squared. So physically, if you don't think of that as something moving, it means that this curve, every point that satisfies xt, yt is a point on this curve. And I'm going to use what we've learned in Calculus 1 about finding the slope at the point 2, 4. To tell you that we're doing the same thing as before, but now I cannot use the derivative because in a more complicated situation, it will not be easy to find this relationship. But this problem is easy. So suppose now I tell you find the slope at the point 2, 4. Using Calculus 1, we find y prime, which is 2x, at x equal to 2, y prime equal to 4, which is the same thing we got whether we use the formula for the parametric curve or we use what we've learned before. So the bottom line is that we're doing the same thing. We're finding the slope of the tangent line. If we can express y as a function of x, we can use calculus 1 to proceed. If the curve is very complicated, that it's hard to find the relationship between them, and then we have to use this new formula we developed. So problem example number 2 is, of course, an example where it's not as simple as that. It's not hard also, and we will answer a lot of questions. So example number 2, again, is the one I gave now on my note. I gave you, let's see, be a curve given by the following equation. The x is t squared plus 1. So for every time t, that's the x coordinate. And for every time t, the y coordinate is t to the power 3 minus 4t. Okay? This is a scenario where finding is not very hard, but it is medium hard to find a relationship between x and y. Not very, but it's medium hard. But I don't want to even worry about it. We can sketch the curve, and I will tell you that your calculators are very good at doing this, and there are a lot of program or apps on the internet that graph them. So if we graph, we get something like that. That's how the graph of this function would look like. And the direction of motion is going, I think, no, it's going this way. And that's the direction of motion. Okay, so if we graph it, we get this. So we're going to ask several questions about this curve. So I will start with the first question for the slope. Question number 1, I want equation of the tangent line at t equal to 3. Sorry. So equation of the tangent line at t equal to 3. First, it's nice to know where I am at t equal to 3. So I will usually like to look at the point on the curve that corresponds to t equal to 3. So what's the point on the curve? If t equal to 3, the x is 9 plus 1, the x is 10, and the y is 27, 27 minus 12, the y is 50. So the point on the curve is 10, 50. So we got it right there, right here, t equal to 3, and that's the point 10, 50. Now my question is, this is the curve, there is a tangent line, I want the equation of the tangent. To find the equation, I need the slope. So let us compute first the slope at every point t, and then at the specific point t equal to 3. The slope is the derivative of y over the derivative of x with respect to time. So this will give me the derivative of y is 3t squared minus 4. The derivative of x is 2t. So this is x prime and y prime. So at t equal to 3, the slope is, now we plug in 3 for t in this equation. I will get 3 times 9, 27, 27 minus 4, the 23 over 6. So the equation would become, now I have the point, I have the slope, and then I can use the point slope form to find the equation. So the equation will become, the point is 10, 15, the slope. So y minus 15 equal 23 over 6 times x minus 10. Okay. Now, question number 2 is the following. So this is a curve, and some places on this curve, the tangent line is horizontal. And it seems like it's somewhere here, horizontal. That's where the tangent line is horizontal. Then it's t cubed. Then the y is t to the power 3. Probably my writing is not very clear. That's 3, not 2. Okay, thank you. So now let's go back here. My question is, for which value of t is the tangent line, so find t, where the tangent line is horizontal. Okay, now back to you. When is the tangent line horizontal? Don't forget calculus 1, because it's the same idea. When the slope is 0, absolutely correct. So what is happening? Tangent line horizontal when the slope is equal to 0. But what is the slope in my particular scenario? The slope is y prime or dy dt, either way, over dx dt. This is equal to 0. But when does this happen? This is happen when dy dt is equal to 0. It means when dy dt equal to 0. And geometrically, this makes sense. The slope is horizontal. The slope is horizontal. It means the y should almost not change in here. That's the slope. For this to be 0, it means the change in y with respect to time should be basically 0. In the y should not change here. Y doesn't change, barely change. That's exactly where the slope is 0. So now this becomes an easy question. Why is an easy question? Because I know dy dt. I just have to set dy dt equal to 0. So we set dy dt equal to 0. But what is dy dt? We know what dy dt is. It means 3t squared minus 4 equal to 0. We solve for t. T squared is 4/3. T is plus or minus the square root of 4/3. It means plus or minus 2 over the square root of t. So the tangent line is horizontal for those values of t. But the question, suppose I ask the question is, at which point on the curve is the tangent line horizontal? So I'm not only asking you when, but also at which point on the curve. So this is my curve now. And I know that the slope is horizontal for 2 different values of t. And now I want the point where this happened. To be able to find the point, it means I need to find, I know when this happened for t equal to plus or minus 2 over square root of 3. I want the point. So how do I find the points now? Okay, all right, I just plug in the value of t in the expression of x and y. So we're gonna write if t equal 2 over the square root of 3, what is my x and what is my y? My x is, no, you guys don't see the x. Okay, this is my x, it's t squared plus 1. So my x is going to be 2 over the square root of 3. I know you don't see, but I will push it up in a second. And 2 over the square root of 3 to the power 3 minus 4 times that. Okay, so if t equal to square root of 3, the point will be, that's the x component, and that's the y component. And you can do a little bit of math here. This will give you 4/3 plus 1. So this will give you 4 over 3 plus 1, which is going to give me 7/3. And the other one, of course, you do a little bit of math, you will get 16 over 3 square root of 3. At t equal minus 2 over 3, also you can do the same and find the point. So you will get plus 1, that's the x, and the y. And you do the math again. The x will not change because the minus is squared. and the y will be actually multiplied by the negative. So this is one piece of the question. Where is the slope 0? And now we found the point. One is 7/3, etc. And this one is 7/3 minus 16/3 root 3. Okay. Now, one more question. When is the slope vertical? Find the values of t where the slope is vertical. So what does it mean the slope is vertical? The slope is like this. Means I'm asking, when does the graph have this shape? So I will just go from whatever you guys have to tell me. So horizontal, it means like this. Basically, y doesn't change. Vertical, any input. And I will accept any input you guys have. Think intuitively. When x prime is 0, and absolutely Sarah is right. It happened when x prime is 0, where the x dt equal to 0, absolutely correct. And I can give you two reasons. First, one reason you can think about it is, this is vertical, it means x really barely changing at this stage. Y is changing, it's going up and up, but actually we don't have really any, x is actually, as you realize, x is really not changing. It means the dx dt has to be 0. Another way sometimes students like to think about it is the following way. The slope of the tangent line is given like that. Okay, so the slope is going to be vertical actually when this actually goes to 0, because when this becomes close to 0, the slope is going to actually blow up to infinity. What does it mean the slope goes to infinity? It means the slope is actually a vertical line. So another way you can think about it, okay, when the slope is vertical, it means when the slope goes to infinity, and this occurred exactly when the x dt equal to 0. So the slope is vertical when the x dt is equal to 0. And now I go back to the x dt. It means my dx dt was 2t equal to 0. It means t equal to 0. And now which point on the graph this would be? I plug in into the original expression. If t equal to 0, my x was t squared plus 1. It means 1. My y was t to the power 3 minus 4t. That's my y. So I go back now to the graph of the function itself. And it's happening right there at 0, 1. And that's the graph is almost, at this stage, the graph is almost vertical. Okay. The last questions before we go is, what's this point here? It means, actually, I want to find when does the graph, at which point does the graph intersect the x-axis? How shall I proceed? Okay, so the last question, does it have anything to do with slope? Okay, somebody draw this graph for me and ask me the following questions. Okay, when do you cross the x-axis? For which value of t? And at which point? How shall I proceed to do that? Set y of t equal to 0. Absolutely. So when does the graph crosses the x-axis? It crosses the x-axis when the y is equal to 0. And that's exactly what we are going to do. So let's see when it crosses the x-axis. So we slowly, we're actually using the formula to slowly analyze the graph. So let's go to the graph right here. So this is going to occur when, so that's my function. So graph C crosses the x-axis when y of t equal to 0. That's when it happens. So now the problem becomes simple. It means t to the power 3 minus 4t equal to 0. And I have to solve for t. So how can I solve for t? One way, I have to factor. Solving is factoring equal to 0. So this will give me t equal to 0. We pick it up from here. And t squared minus 4 equal to 0, which give me t equal plus or minus 2. So, thank you. So when does c crosses the x for t equal to 0, for t equal to 2, and t equals minus 2. Now at what point? So now we have to find the point. To find the points, I go back and substitute into the expression of the curve. At t equal to 0, my x is 1, my y is 0. So that's the first point. So on the graph, I'm picking up that. Now, what's the other point? Okay, at t equal to 2, which point we're picking up? My x is t squared, so I put my x here instead of pulling the paper every time, and I put my y in here. So what is my x? My x is 4 plus 1, that's a 5, and I know this is 0 because that's exactly what we're doing. And minus 2, what do I get? Again, 5, 0. So this tells me that, of course, we notice that we have the same value here. So this tells me that at this point, so this is my 1 and this is my 5, 0. So we hit this point for two different values of t, which it's not really something weird. We hit it for t equal to 2, we're right here, sorry. For t equal minus 2, we're gonna back here, and then we go around, 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 back, t equal to 2, we cross our path again, and then we go on. And that's really, we have two different values, and they give me the same point because we're crossing this point twice during, our motion. Right, I think I'm definitely out of time. I still had one idea to talk about today, but I will postpone it for tomorrow because it's not much. It's just a formula of the length of a curve when the curve is given parametrically. How do we find how long the curve is? Okay. Any questions before I let go? Please do the homework. I strongly encourage you to do the homework. I did when I was seeing you. Now I don't. Please do them. That is the only way you guys will carry the knowledge with you. Okay? Any questions? All right. Bye-bye, guys. I see you in Zoom for those who would like to join me.